Hello, I am Tom Tattersall, Executive Vice President of the MicroCare Corporation. MicroCare is a leading supplier of cleaning and coating fluids to the global marketplace. We are DuPont's Vertrel Cleaning Fluids premier partner or supplier for the product line in North America. You can learn more about MicroCare on our website, microcareprecisioncleaners.com. Many engineers may not be familiar with the vapor degreasing process. The vapor degreasing process has been around at least 60 years, as it was developed to clean high-volume applications such as automobile parts manufacturing, appliances, aviation components, which were needed after World War II. The introduction of the circuit board introduced new cleaning requirements and high-volume requirements, where the vapor degreasing process gained widespread acceptance as the preferred method of cleaning. Halogenated solvents based on chlorine, bromine, and fluorine were the cleaning fluids of choice with this process. As the ozone issue of the 1990s took place, many manufacturers had little choice but to design aqueous cleaning systems for their cleaning needs. Now that many of those systems approach the end of their useful life, vapor degreasing is a worthwhile cleaning process to evaluate and select, especially where critical parts or critical cleaning needs are in play. There are many advantages for the customer with this process method. So, why would you use the vapor degreasing process? Here I have listed a few of the more significant advantages. Once the cleaning process is installed and validated, very little monitoring is necessary to produce clean parts day after day. The manufacturing engineer and his or her lab do not have to take daily samples to ensure the chemistry or water effluent meets their requirements. Sensitive parts and materials will not flash rust with this method. The process does not require any additional drying step. Parts with extremely small openings or blind holes can be cleaned effectively and consistently. The process is highly energy efficient, leading to lower operating costs. And finally, the footprint of the vapor degreasing machine is significantly smaller than aqueous cleaning systems. In general, less capital is required to install. Vapor degreasers offer a very flexible process and are available in multiple sizes to handle anyone's cleaning and volume requirements. Here are a few design parameters which are questioned and discussed in any project. The answers help determine the size of the vapor degreaser to specify. A key point to remember is that a solid equipment design up front assists in minimizing solvent loss during its operation. This leads to lower operating costs for a customer's cleaning process. Vapor degreaser manufacturers exist worldwide, each with their own design twists for you to evaluate. One final note before I turn the webinar over to Mark: the vapor degreaser should be considered an elegantly engineered machine. It cleans, rinses, dries, and recycles all in one unit. I will discuss later in this session facts how to minimize solvent loss. Before that, however, let me introduce Dr. Mark Robin of DuPont. He will lead the discussion on vapor degreaser cleaning fluids.
Good morning, good afternoon, or good evening, depending upon your location. I'm Dr. Mark Robin, Senior Technical Services Consultant for DuPont Chemicals and Fluoroproducts. Thank you for joining our webinar, which we hope will provide you with an understanding of the unique properties of DuPont Vertrel specialty solvents. During this session, I will provide a review of the Vertrel product line and discuss the core criteria for specialty solvent selection and how Vertrel fluids provide the best overall combination of the properties desired in a cleaning solvent. The Vertrel product line of specialty fluids is based on Vertrel XF, the basic properties of which are shown on this slide. The molecular structure of Vertrel XF, in particular the location of the two hydrogen atoms within the molecular chain, imparts to Vertrel XF a unique combination of properties which make it an ideal solvent by itself or in combination with other solvents for a myriad of applications. Vertrel XF has a relatively low boiling point of 55 degrees C, is fast drying, non-flammable, and characterized by low toxicity. The Vertrel product line is comprised of Vertrel XF used alone as a neat solvent and numerous blends of Vertrel XF with other solvents. By combining Vertrel XF with different co-solvents, the solvency power of the resulting multi-component solvent can be adjusted, allowing one to fit the solvency power to that required for a particular application. For example, the kb values for Vertrel products vary from 11 to over 100. Vertrel XF can also be employed as an inerting agent, where it is mixed with a flammable solvent or solvents to provide a solvent of reduced or no flammability. The ability to mix Vertrel XF with other solvents can also be employed to improve the toxicity profile of the other solvents. This slide provides a summary of the Vertrel product line and indicates the major Vertrel solvents. As seen in the chart, Vertrel specialty fluids are suitable for a very wide variety of applications. Vertrel XF itself finds application primarily as a carrier fluid and rinsing media, and is also suitable for some light soil cleaning and particulate removal. Vertrel XF is also suitable as an ingredient in aerosols and as a dielectric coolant. The Vertrel XM, XE, XH, and XP products are suitable for light soil cleaning, particulate removal, and wipe cleaning. Medium and heavy soil cleaning, degreasing, defluxing, and silicone removal are readily accomplished with the Vertrel SDG, SFR, SMT, MCA, and MCA Plus products. Due to their high solvency power, low surface tension, and non-flammable properties, Vertrel SDG and Vertrel SFR in particular are excellent solvents for use in vapor degreasing applications. For water displacement type drying applications, Vertrel XDA and XDF are suitable solvents. For absorption drying applications, in addition to silicone deposition and removal, Vertrel XP10 or XSI are suitable solvents. In the case of precision cleaning, the industry demands solvents meet a core set of criteria which includes material compatibility, solvent stability, and solvent effectiveness. High compatibility with metals, plastics, elastomers, and organic materials is required to prevent destruction of materials, equipment, and parts that come into contact with the solvent. High solvent stability is a critical requirement. For example, eliminating the need for acid stabilizers reduces the cost of solvent maintenance, replenishment, and replacement. Finally, high solvent effectiveness is desired. DuPont Vertrel specialty solvents meet or exceed all minimum criteria related to material compatibility, solvent stability, and solvent effectiveness, which permits us to offer to customers the assurance that our solvents will perform consistently, remain a quality product from delivery to use, and provide safety in use to workers. As previously mentioned, high solvency power is a key criteria for solvent selection. As seen in this slide, Vertrel fluids offer a wide range of solvency powers, as measured by kb values ranging from 11 to greater than 100. For example, the solvency powers of Vertrel SFR and Vertrel SDG are close to those of NPB, making these solvents ideal replacements for NPB in precision cleaning applications. Worker safety is another key consideration in solvent selection. To ensure safety in use, the toxicity of a solvent should be as low as possible. Vertrel fluids are characterized by low inhalation toxicity and, as a result, pose little risk of adverse effects when airborne exposures are maintained below established limits. Vertrel solvents are also characterized by high evaporation rates. Quick evaporation reduces cycle times and improves profitability. The Vertrel solvents are also characterized by low global warming potentials, or GWPs, and these low GWPs, along with very low levels of emissions, results in the use of Vertrel solvents having a minimal impact on global warming. Switching from other solvents to Vertrel solvents does not incur any environmental fees, and Vertrel solvents can be readily recycled and reused. In addition to toxicity considerations, solvent flammability also impacts the ultimate safety and use of any solvent. Most Vertrel solvents exhibit no flashpoint in closed or open cup tests and are hence classified as non-flammable liquids. As pointed out in the previous slide, exposure limits are a key criteria for solvent selection. This slide compares the exposure limits for Vertrel with that of a variety of solvents. As seen in the graph, Vertrel offers the lowest level of toxicity of the indicated solvents, especially in comparison to NPB. It can also be seen from the graph that the exposure limit for Vertrel is higher than that of rubbing alcohol, That is, Vertrel is less toxic than rubbing alcohol. Physical properties of importance when selecting a solvent include the boiling point, vapor pressure, and latent heat of the solvent. The boiling point should be low enough to allow easy separation of the solvent from greases, oils, and other contaminants by a simple distillation. The boiling point should also be high enough that the condensing coils of the vapor degreaser can function effectively using water. A low boiling point will reduce the time and energy required to reach the boiling point, and will also reduce the time required for parts to cool down to the point where they can be handled or transferred to the next process. In both cases, a lower boiling point translates into increased throughput. A low vapor pressure is desirable, as this will provide higher evaporation rates and hence reduced cycle times. A low latent heat provides increased mass of vapor per unit of heat input, reducing the cost of vaporizing the solvent. In addition, a low latent heat provides more rapid boiling and drying, decreasing energy costs for these processes. A low latent heat also provides a higher evaporation rate, reducing drag-out losses. Additional physical properties of importance when selecting a solvent include the vapor density, surface tension, and viscosity. A high vapor density allows increased solvent vapor recovery and reduces solvent losses through work transfer and airflow disturbance of the vapor blanket. Low surface tension provides an increased ability of the solvent to penetrate tight spaces, allowing thorough cleaning of complex precision parts and components. Low surface tension also reduces clinging of the solvent to the part being cleaned, reducing drag-out losses. Low viscosity is also desirable, as this increases the ability of the solvent to penetrate tight spaces and helps reduce drag-out losses. The use of fluorinated solvents, such as the Vertrel fluids, offers a number of advantages over aqueous-based solvents. Foremost is the improved cleaning of precision parts and components. The low surface tension of fluorinated solvents like Vertrel allows the solvent to penetrate tight spaces, leading to improved cleaning of complex parts. The use of fluorinated solvents avoids the complex, time-consuming, and expensive monitoring of wastewater effluents and eliminates the need for wastewater treatment. The use of fluorinated solvents also eliminates problems associated with corrosion and contamination of parts, for example by surfactant ingredients, which can occur with aqueous-based solvents. Due to their ease of vaporization, the use of fluorinated solvents requires less power consumption and reduced equipment sizes, and a separate drying stage is not required with the fluorinated solvents. Two of the most widely employed Vertrel solvents are Vertrel SDG and Vertrel SFR. Vertrel SDG is ideally suited for use as a silicone carrier fluid for silicone grease removal, oil, grease, and wax removal, and for precision cleaning. Vertrel SDG meets or exceeds the core criteria for a solvent. It has excellent solvency power with a Kb value of 95, a low boiling point of 43 degrees C, is low in toxicity, and is non-flammable. These properties, along with its low surface tension, make Vertrel SDG an excellent ultrasonic vapor degreasing solvent. Vertrel SDG also has the desirable properties of low latent heat and high vapor density. Vertrel SDG is compatible with a wide range of materials, including metals, plastics, elastomers, and organics, and can be employed in vapor degreasing equipment with little or no changes to the equipment. Vertrel SFR is ideally suited for use in defluxing applications, and also for oil, grease, and wax removal, and for precision cleaning. With Kb values approaching that of NPB, Vertrel SFR and Vertrel SDG are excellent replacements for NPB in vapor degreasing applications. Vertrel SFR is compatible with a wide range of metals, plastics, elastomers, and organics, and can be employed in vapor degreasing equipment with little or no changes to the equipment. In conclusion, Vertrel specialty fluids provide the best overall combination of the properties desired in a solvent. A wide range of solvency allows for a best fit of the solvent to the application, and with Kb values up to and exceeding 100, Vertrel fluids are capable of removing the toughest soils. This wide range of solvency is accompanied by low toxicity, high material compatibility, low environmental impact, and economical operation. The Vertrel fluids are highly stable. The addition of stabilizers is not required, Hence, the use of the Vertrel fluids is essentially maintenance-free. Since their introduction in 1993, the Vertrel fluids have proven to be an excellent choice for precision cleaning applications. At this point, I'd like to turn things back over to Tom Tattersall. In this third section of our webinar, Tom will detail techniques for minimizing solvent losses and provide a selection of case histories of high-volume parts cleaning with Vertrel fluids.
Thanks, Mark. So far, we have discussed the vapor degreasing process in terms of benefits, design, and cleaning fluids. I'd like to spend a minute or two on other areas where solvent loss may occur. That's work practices and maintenance procedures. Now that you have your vapor degreaser installed, let's be sure to use and maintain the vapor degreaser properly so we take advantage of its savings potential. The degreaser should not have or be near direct ventilation. We want to protect the vapor blanket and limit diffusional losses. This disruption leads to vapor losses. How one arranges the parts and how many parts are in each cleaning basket affects not only solvent loss but cycle time. You want the parts to be easily drained and the basket not so heavy as to shock the system. Take advantage of the degreaser to be used as a recycle machine when you have determined it's time to empty the dirt or soil you have cleaned off the parts. Finally, recording solvent use greatly assists the operator to get advance notice that something has changed and he can begin to troubleshoot. I offer these listed tips as good practices when working with a vapor degreaser. Inspect the solvent addition log. Unexplained changes in addition levels should be investigated. Using a leak detector to inspect for leaks is recommended on a routine basis. Remember, many solvents evaporate quickly on small leaks. Solvent addition and draining should be designed to be closed loop if possible. At a minimum, the use of pumps should be practiced. Identify, communicate, and use proper protective equipment when performing maintenance. Train your employees on operating procedures and these tips to minimize solvent use. Let me conclude this webinar with two case histories of large volume manufacturers who demonstrate the benefits of vapor degreasing. This customer faced the need to increase cleaning capacity as their business grew. They had a space limitation and energy costs were high. We were able to design for them a vapor degreasing process that not only freed up factory floor space because we removed the old aqueous lines, but also increased cleaning capacity. Furthermore, we designed a custom oil recovery system which purified the oil enough for it to be reused, which saved additional dollars. We reduced energy costs 90%. Most importantly, their cost per part clean was reduced. And this company cleans upwards to 50,000 parts per day. The second customer case history involves a manufacturer who had a cleaning capacity increase need and also a safety concern to eliminate flammable solvents from their process. Their parts not only had a complex geometry, but in many cases exhibited some porosity. We were able to design a vapor degreasing process that met their safety goals through the use of a non-flammable solvent, plus we were able to increase their cleaning capacity. Once again, the cost per part clean was reduced. They tell us this vapor degreasing process will give them enough capacity until 2015, at which time they will install a second vapor degreaser. These two examples, one replacing an aqueous cleaning line and one replacing a traditional dip and dunk system using flammable solvents, highlight well the benefits of the vapor degreasing process. To note, both examples switched to a Vertrel-based cleaning fluid. We thank you for your participation. If you have any further questions, please feel free to contact us at the information provided on the screen. Thank you.